All right, so hello, welcome everybody to my talk. My name is Jonas Gehrlein and I work for the Web3 Foundation. Okay then, hello again. My name is Jonas Gehrlein. I work for the Web3 Foundation as a research scientist. And at the beginning, I want to give a little bit of a context to understand my talk. We all know that the staking system is the backbone of Polkadot. And because it provides the economic security to all the parachains, or now called cores. And here, the validators are actually a very important part of this because they are kind of shielding the economic attacks towards the outside, or they are actually, needing to withstand these economic attacks. And for all blockchain protocols, it's quite difficult to determine how to actually find the active set of validators to protect against these economic attacks. And in Polkadot, we applied a nominated proof of stake algorithm that employs a second set of very important actors, which are the nominators that are tasked to find these active validators and to make a kind of an informed opinion of which of them should be in the active set by actually delegating their stake, and thereby, by wisdom of the crowd, find a very resilient set of active validators. So this is a very important task, but also validator selection is very complex. I'm sure many of you are nominators and try to find these kind of active or these validators which you should include in your nominations. And basically the task is to select a small subset of all the available validators on Polkadot. And ideally, nominators want to select up to 16 validators. This is because they want to make sure that they are always ending up with an active validator, so they are always earning rewards. They also want to kind of diversify their selection. And from the protocol side, it's also quite important because then the election algorithm can uniformly distribute the stake and has enough degrees of freedom to do so. But the task basically is to select 16 validators out of 1,000, so like 300 active ones and 700 waiting ones. So this is quite a challenging task. When we look at the data, we can see that this kind of works quite nicely. The nominators, on average, have a very high number of nominations. So I think on average, like 10 or 11, so that works quite nicely. But if we look at some other data, it doesn't work so well. So 77% of the nominators that have been active for the last 6 months, maybe longer, did not update their nominations. So it could be that, of course, they are frequently checking and finding that their selection is still optimal and not changing anything, but it's a kind of a strong signal that they might just set it once and then forget, right? And as I said before, it's quite the important task for nominators to go through the set frequently and try to find the optimal selection. So, and one main reason that I think is that it's very cognitively demanding to do this task. And I'm sure many of you can relate when you find this big wall of validators, and it's very hard for you to kind of make a good selection. So I want to show you some of the trade-offs that you can face when selecting these validators. One important dimension is the economic security, which basically means how resilient is a validator against economic attacks from the outside. And here one very important criteria is the self-stake, because that is the stake that the validator is basically nominating themselves with. And in the situation where they have some offense, they will get slashed, and it's for sure that they will lose this stake. But then also something that not many people maybe realize is that also the commission is important here, because a high commission, given that the validator is active, means that they are earning more in the future, which makes them, wanting to be in the set in the future or now, right? So the higher the commission, all things being equal, make them more economically resilient. But then from the perspective of a nominator, of course, nominators also try to increase their payout, their staking rewards. And here we can already see some kind of disalignment between the two dimensions, because, of course, for the profitability for the nominator, it is important to have the commission kind of as low as possible. And then we can also define maybe a third dimension, which is the decentralization. So some of the operators have many different nodes. So one operator has many different nodes. And for some people, this is a positive signal where they say, OK, they are quite invested. They have a very professional infrastructure. But other people might say, I rather want to have a more diverse set of validators, and I'm actually trying to minimize the amount of nodes that each of the each of the validators has. And now we can already see that there's like this trade-offs between all these dimensions, especially when we realize that all these criteria are on a spectrum. Right, so it could be that some nominator is actually willing to sacrifice a little bit of profitability to increase the economic security of a validator or to increase the decentralization. Or maybe they are willing to sacrifice a little bit of economic security to increase the profitability. So here we can see that this is a very individual evaluation. And we need to kind of acknowledge that different nominators have these different preferences, but in aggregation, we think that it leads to a good set of validators. So I kind of set out to find a decision aid that is actually helping nominators to make these decisions more easily. And I have some criteria for myself which I wanted to fulfill. So it needs to be fast and easy, because otherwise people just won't engage with it. It needs to be unopinionated, which is quite important, because I don't want to have a curated set of my favorite validators and I keep publishing it and hope that everybody follows. And the only way to achieve this is that it's user-centric, right? So we kind of acknowledge that there is these different trade-offs, or that there are these different trade-offs, these individual preferences, and we actually need to cater to this. And then I also wanted to have it data-driven, because we have the blockchain where information is trustworthy and we can verify it. And I didn't want to complicate it too much with like qualitative data. So it turns out I looked in the literature, and that the active learning literature is actually perfect for this, but they didn't apply this to the blockchain space yet. So I teamed up with a bunch of cool researchers to actually use this framework that has already been developed in academia and apply it to this problem. And for the sake of this talk, you can imagine that this active learning algorithm is kind of a magic black box, and the nominator keeps interacting with it, and the algorithm kind of learns the preferences of each nominator, and at some point it says, OK, I learned enough about you. I can actually give you a recommendation of which validators are actually suitable for you. So I want to describe a little bit about the journey, and some of you might have seen the talk last year. So we started out with the theory. We adjusted the theory from the academia to fit our use case. We developed a prototype. Then we also have made an experiment and a scientific study to test whether that our thing actually works and helps people. And now we are at the implementation phase. And here I'm quite happy that kind of the research side is kind of completed. We were able to publish our paper in a very well-renowned peer-reviewed journal in this field. But I also think that research should always be applicable to the real world. There's no like value in just doing research and put it in some journal and nobody kind of applies it. So this is why I want to kind of introduce the validator selector here, which is an unbiased, decentralized decision aid. And I want to give you a live demo about this. So here we see the user interface. It's not finished yet. It's a first draft, but it's actually online, so you can later try it out. And now here we can see that the algorithm kind of asks you whether you prefer validator A over validator B, and it gives you the different criteria here. So we have the self-stake, the commission, the average error points, which is some indicator about the performance of the validator. I might actually want to change this to some staking API, so it's easier to compare. And then the cluster size, which is basically an indicator of how many nodes this validator operator has. and the number of votes, which is how many nominators are nominating this validator, but before the algorithm kind of smoothen this out. So it's kind of a measure of popularity. And now it basically asks you, which of the two would you prefer? Like, which fits your criteria or your preferences better? For me, for example, I would say that I want to have a high amount of self-stake. The commission looks fine with 5%. The error points are quite comparable. Personally, I try to minimize the number of clusters. And for the popularity, I'm fine. So now it tells me, well, the precision is not high enough. I don't know too much about you. Please keep going. And here I would again say that for me, it's quite important if I nominate an anonymous validator that the self-stake is quite high, even though that the commission is higher. And here's the same thing. It asks me, well, do you want 1 dot as self-stake or 5,000 dot? And to me, this is like already a deal breaker, so I'm going for this one. And again for this one. And now it kind of understands, OK, he wants to obviously have a high self-stake, so I don't care about this criteria anymore. So I set them equal. And now I try to understand the other criteria. And here, I would probably go for the lower commission. And it already kind of understood, OK, I have already enough information about you. So it produces this output, but I want to keep going. And here, I think 1,000 dot is quite good. 10% might be a bit too high, especially if we see that the other one has more self-stake. And the cluster size is smaller, so this is fine for me. Now it actually set commission and self-stake equal. And the cluster size, so yeah, I don't care too much about the number of votes, and I actually want to have a little bit more performance, so I'm here. And now, it basically gives me this output where it says, and it has all the validators, and it orders them by score. And it says basically those 16 are the ones that suit you the best. I could load more. So basically, we have a score for every available validator, but we just sort them by default depending on the score. And if I see now, it sounds very reasonable for me. The first one has a lot of self-stake, a low commission, and high error points, and low cluster size. And due to time, I won't go through all of this, but it seems quite reasonable to me. All right. So this is an unopinionated tool. We make only minimal assumptions. So we have no validator favoritism. There's no notion of this validator is per se better than the other one. It's user-centric. So it depends on your path that you take. So if you answer the first one as A, and then the second one as B, the questions would be different than if you answered the first one with B and then with A, right? So it really tries to understand your preferences based on the path that you take. And we have a very broad representation. So around 90% of the validators that have less than 100% commission, because they don't make much sense to actually present here, are represented in at least one of the final recommendations. So there's no real discrimination here. So all validators can be reached by some path here. It's fully decentralized, and that is something that I'm really excited about, because it's powered by the Light client. It uses Small.dot, and there's no backend and no REST API. So all the data that you saw was actually gathered in the front end through the Light client. And we gathered data on 300 validators, and actually for the past 40 eras, which is a long time, and all of this in less than 30 seconds, which is actually amazing. And yeah, the data collection is always new, so it always takes the newest set of validators. It's also accessible, so it's of course free to use. It's open source, and everybody can fork it and customize it and do whatever they want with it. And I'm quite also excited to have talked to Ross to have actually some kind of implementation between the validator selector and the staking dashboard. So our first idea would be that you export the recommendation and you are able to import the recommendation into the staking dashboard and then directly make the nomination there. Have some process, so what happens if you already have a nomination, like how do you want to proceed with that? Or actually at some point maybe integrate it completely into the staking dashboard. And this is, I think, a very cool way to actually optimize and share your nominations. Because to me, actually, I have a lot of like personal experience where some people said, like, oh, I have a few dots, but which validators do I take now? And for them, maybe it's fine enough if I just share my recommendation with them and they just import it and get going, right? Instead of actually sitting together and then kind of trying to find the validators that I also have or some other maybe not optimal process here. And this also opens up all the different ideas for here, because other people could create their own tools, could create their own recommendations. Maybe some people would publish their actual set of validators that other people could follow and just import into the staking dashboard. A little bit like the nomination pools, but of course you're still in control yourself. And I'm here standing on the shoulder of giants. I couldn't achieve this without some amazing co-workers. So Gregor Schmiebs, who is actually also a co-author on the paper, and he now joined Web3 Foundation, who did a lot of great work on the algorithm itself. Then Josep from Parity, who did amazing work with the Light client and actually made it possible to get these kind of data so quickly and so efficiently in the front end. And then Daniel, who made a very nice experience in the UI. Yeah, it's just great to work with them. It was an amazing collaboration. So what's next? So I actually want to have like kind of an iterative approach here. I want to gather feedback, actually put it out in the wild, have people use it, and then be open for feedback and try to optimize the whole process. And I want to extend the whole process to inactive validators, because they cannot be compared properly with active ones, but find some way to actually mix in some inactive validators. And then a very important thing is to have multiple stashes, because you don't want to nominate probably all the same nomination with all the stashes, but have some diversity there. And yeah, you can try it yourself. Just write me an email if you need the link. You can copy this link, tinyurl.com, selection decoded. It's all also available in the so it's adaptive. You can also have it in the mobile on the smartphone. And yeah, thank you very much for your attention, and I'm open for questions. Actually, we don't have time for questions. Okay, so no time for questions, but I'm available later. Of course, if you have questions, come to me.